Hello everyone. In this video we're going to see a solution to this problem. Find the volume obtained when the circle of radius 1 with center 1, 0 is rotated about the y-axis. So first we're going to draw a figure so we have an understanding of exactly what this shape is going to look like. If this point is the center of our circle and the circle has a radius of 1, then it is going to pass through the origin. And rather than trying to compute the volume directly, what we're going to do is consider a horizontal slice out of this circle. We'll say that this slice is taken at an arbitrary value of y. And we're going to think about what happens when this line segment is rotated around the y-axis in the third dimension. So what we want to do is try and visualize what shape this is going to make. If we picture it from above, the resulting shape is going to be an annulus. So an annulus is basically a disc with another disc removed. So this is the shape as seen from above that's going to be traced out by that one line segment. The thing that's going to be important here is the inner radius, which we'll call R1, as well as the outer radius, which we'll call R2. Now, if we compare this figure to the one we have above, the inner radius, R1, is going to be this distance here, and the outer radius is going to be this larger distance here. So let's label them on this figure. This is R1, and this is R2. The next thing we want to do is we want to find expressions for R1 and R2 in terms of this arbitrary value of y. And we're going to do that by using the relation which defines this circle. So it's a circle of radius 1 with a center at 1, 0. So the formula for this circle is given by the following. And I'm going to solve for x in terms of y in this expression. We are going to take both the positive and negative values of the square root here. And so what I have now, for an arbitrary value of this parameter y, I have two values of x, one of them corresponding to the negative value of this symbol and one corresponding to the positive value. And those are going to give me, these two values of x are going to give me the inner radius and outer radius of the annulus. Now what I want to do is I want to compute the area of the annulus for any particular value of y. I'm going to denote this by a of y. The way we compute the area of an annulus is pretty straightforward. We compute the area of the outer circle, which is equal to the following. So the outer radius is the one that corresponds to the positive sign here. So we square that radius and multiply by pi. This gives us the area of the circle. And we want to subtract the area of the inner circle, which gives us this. I'm going to expand this expression because we're going to get some nice cancellation. So what do we have here? For any value of y between -1 and 1, this represents the area of the annulus that gets swept out by a slice of the circle. In order to convert this to a volume, we're going to want to integrate this through all values of y which are relevant. Y is going to range from -1 to 1. So now I'm left with an integral that I need to compute. This integral can be simplified with a trigonometric substitution. So if I make all these substitutions into the integral and also change the bounds of integration appropriately, then I get the following. I'm going to use a simple trig identity to make a substitution for cosine squared. And now we have an integral that we can do using direct techniques of integration, knowing the antiderivative of straightforward trigonometric functions. And the final volume we get is 2 pi squared. If you want to see my thought process and how I came up with the solution, check out the process video, which is linked here. Thanks for watching.